everyone, welcome to the lecture 7 of NPTEL course named Climate Change in Extreme Events. In the past two weeks, we have already discussed about what is exactly climate, what is exactly weather. We have discussed about multiple weather events, climate events also. Then we have also discussed about different types of data set, particularly rainfall, to understand about what is exactly how we can tell about the climate is changing or not. Then in the second week of this course, we have already introduced several different types of climatic extremes, starting from the temperature extremes, then precipitation extremes, then weather related other extremes, and then we have also done some sort of hands-on exercise on how do we classify, let's say, which area is highly vulnerable based on prior historical flood data set or let's say drought data set, and then we can also look at the annual behavior of floods and drought anomalies across that particular region. Specifically, we have talked about district level analysis in the Indian region or Indian scale. In this week, the week 3 of climate change and extreme events, we will particularly look at the data sources. Then we will also discuss about what is the data handling processes. Then we will also discuss about what is exactly climate modeling in broader sense, or some very fine details of those modeling also. In the today's lecture, we will primarily focus on what is exactly climate data source, the observation tools which are available, for example, satellite data sources, ground based observations and remote sensing, and particularly we will also talk about there are several hybrid data set which is called reanalysis product, and how we can use those data set to get an idea about, let's say, is there any meteorological property has been changing over the past few decades, or let's say in the recent time we observed any significant trends of any particular meteorological or land use land cover characteristics which can directly or indirectly correlate with the climate change impacts. So, in this particular lecture, we will first go through the key sources of climate data set, where we can take these data set and we can analyze different types of climate data parameters. Then we will also explore some of the satellites, ground stations and remote sensing climate observations that can also be very important when we talk about climate extremes, climate modeling in different parts of the world. Then we will also recognize the strengths and limitations of different data tools, data process which we have already, and then we will examine some of the application or case study based on some sort of different data sources, observed data or reanalysis data or some sort of satellite based observations like that. So, why climate data matters? When we are talking about, let's say, long term global climate trends or long term, let's say, changes in the temperature, precipitation, or let's say if you are talking about how the snow melt is increasing, the rate has been increased, or which area in the, let's say, Himalayan region or Arctic region or polar region has been suffering from increasing amount of melt in the past few decades, then it is very important to look at what is the data, what the data is telling actually. So, data basically can give us a trend where is there any change in the specific property of the climatic behavior in past historical some years, and is there any trend, for example, increasing or decreasing trend, whether on the basis of that we can interpret whether it is increasing or whether it is decreasing like that, and what would be the impacts on different types of climatic processes like that. Data is also very important when you are talking about, let's say, extreme weather events. So, that will basically tell us about in what historical period that extreme floods or droughts or extreme temperature or heat waves or let's say multiple different types of extreme events has been occurred, and then based on that record or historical frequencies or magnitude, we would be able to prepare for some sort of preparedness measure or mitigation step or some sort of risk assessment on those regions like that. It will also, very important to look at some sort of policy and decision making tool to look at the historical trend, what has been historically the data has been captured in one particular region, then we will plan accordingly, and then we will try to calculate the risk or mitigation step, and then we will include let us say in state level or local level or country level decision, so that we can minimize the risk of that particular impact of climate extremes on that particular regions, like that. So, this is the primary importance factor, which is why we do some sort of data analysis or data data based informed decision on various types of climate data sets. So, when we have, let us say, multiple data set, it can be used for climate modeling, which can basically tell about, which can work on the historical time period, and then can forecast in future time step, or can predict future scenarios based on multiple different greenhouse gases scenarios, like that. When you have, let us say, historical data, we can project for future, and when we have, let us say, scenario based assessment, then we can prepare the plan, for example, for more effective or risk reduction strategies, or let us say infrastructure planning, or let us say if there is some frequent floodings events or drought events are occurring, whether any kind of infrastructure design implementation on those areas can basically improve that conditions or not, like that. And then also we can able to make some sort of response, emergency response. Therefore, the climate data is very important, which basically can give us an analysis and modeling, and based on that we can do some sort of forecasting of extreme events or predictions under different scenarios, and then we will, based on that, different future extreme conditions or historical observations, we can inform the policies, or basically can make a policy to implement or to further reduce the risk associated with those extreme events, and that will help us to basically disaster preparedness and response for that particular regions, like that. So, there are several data types. One data types is ground based observation tools, or basically these are the devices which are installed several places. For example, there are devices like weather stations, which basically measures the temperature, precipitation, humidity, wind speed continuously at one particular point or location. And there are several a network of weather stations across different parts of particular region, which can basically tells about, let us say, what is the temperature fluctuation spatially, what is the temperature fluctuation precipitation, or let us say spatio-temporal pattern of humidity and wind speed also. That can help us to give more better insight about what is exactly weather pattern, or how it is basically connected with the changing climate change or climate patterns, like that. So, these weather stations generally installed in ground areas, or let us say in the different parts of the country where we have several weather stations. It is also installed in high mountainous region, for example, Himalayas, or let us say very multiple areas, so that we can have a better understanding about different types of weather parameters. Then we have also ocean buoys, which are basically installed in the ocean surfaces, where the purpose of these devices to monitor the sea temperature, what is the changes in the salinity, what is the changes in the wave heights, ocean currents, like that. Then we have another devices called radio sonde, which is basically used for upper atmosphere data collection, which is used for aerosol interaction, which is used for multiple different types of upper atmosphere interaction properties of those particular regions, like that. So, here it is showing the one particular type of weather station, where multiple devices are installed in one area, where it is collecting the data of different weather parameters. This is a ocean buoys instrument, which is basically a floating kind of device, which continuously measures the sea temperature, salinity, wave heights, and ocean currents, like that. And this is a radio sonde device, which basically installed in one balloon, which balloon basically goes into the atmosphere, and that collects the data of one particular location, about the upper atmosphere and all these interactions like that. So, these are some of the ground based or altitude based, where we are installing the device at certain heights, or there are some devices which are installed in the sea surface base. So, these devices basically record some sort of high accuracy data set, and which can also be sometimes be used for very long terms of data set to understand, let us say, how the climate patterns has been changed in that region like that. The limitation of these types of observational tools is these are actually measuring the point information of one particular location. Therefore, it has some sort of limited spatial coverage, and there in these devices, let us say if these devices are installed in very remote areas, that can also lead to a maintenance challenge in, let us say, Himalayan region or some region which are very far away from city cluster or something like that. There is a chances of limitations of maintenance and all those things which is associated with these types of observational. However, when we have observational record, it will always give us a very high accuracy record of any different types of properties at one particular locations like that. Then there is another types of observation is called satellite based observations, which basically a continuous observations from when the satellite was launched and till date, if it is working, it basically continuously recording the data which is let us say atmospheric data or hydrological data or some sort of land use, land cover characteristics data like that. And these satellite data sets can also cover whole globe, that is also called global data collections like that. Satellite observations also as I just suggested monitor atmospheric interaction, oceanic changes, terrestrial systems like that. So, everywhere you can have a monitor or monitoring system based on satellite observations. Some of these satellites are, let us say, if you talk about NOAA's GHOST satellite, ESA's European Space Agency Sentinel program, or NASA's Aqua and Terra satellite, which is also MODIS data set, can be used for multiple different purposes, global data set which is used for. These different satellites and all measures multiple different parameters, for example, weather parameters like temperature data set, or for multiple multiple years or multiple different resolutions. It can be daily, sub-daily or monthly or weekly or yearly temperature data set. It can also give us the cloud cover data when we have higher cloud, when we have lower cloud like that. It can also give us the sea level changes also. So, sometimes when you are installing, let us say, oceanic instrument at some point of time location, it might possible that it will record the data for one particular location. However, when we have satellite observation for whole broader coverage of that oceanic body, we can tell about, let us say, what is the spatial distribution of sea level change or changes in any types of oceanic let us say behavior. Let us say maybe it can be salinity, it can be temperature, it can be sea level change. For a broader region, we can tell about using the satellite data set. In the atmospheric, we can also measure the greenhouse gases concentration, how it has been changed historically, and is it increasing in one particular location or another particular location like that. So, for example, TROPME, which is installed in Sentinel 5P, can be used for this kind of measurement and all. So, when we talk about remote sensing dataset, remote sensing dataset can be classified into two types, broader category. One is called active remote sensing, another is called passive remote sensing. So, active remote sensing, you can understand that those remote sensing method where there is a device in the satellite system is also installed, which continuously throws the radiation towards the target. On the other hand, if you talk about passive remote sensing, that is the remote sensing data capturing technique where we do not use on board energy emitting system However, we use secondary source where the energy is emitting and interacting with the target. For example, secondary source in our case is sun, where multiple radiations are emitting, and that's basically interacts with land use, land cover characteristics, and that is basically reflect back to the sensor or multiple direction, and which direction the sensor is located. It is basically capture the the interaction between the electromagnetic radiations with the land use, land cover properties or atmospheric properties like that, and it will record the the reflectance value, or how much amount of electromagnetic radiation has been absorbed by that particular region like that. So that is called passive remote sensing. So there is a difference between active and passive remote sensing. Active mainly used when we do not need any secondary source. However, passive is basically when we have secondary source and we are relying upon that electromagnetic spectrum like that. Both the methods have some sort of shortcomings or advantage. For example, in passive remote sensing, we are totally dependent upon natural radiation systems. Therefore, if there is a night, then it is difficult to capture the radiation which is coming out from the target, because we don't have sufficient electromagnetic radiations in the sufficient the spectrum where we are interested in. Or active remote sensing, let's say we need some sort of sophisticated instrument everywhere which can record the data set continuously like that. So these are the techniques which are used for collection of the data set. It can be your land use, land cover characteristics, or it can be your climate data characteristics like that. It is basically, these are the methods which basically generate the data. So for example, if you talk about deforestation mapping. So if you are interested in, let's say, if there is a certain region where the heat waves are increasing continuously, and is there any correlation between, let's say, forest cover change in the heat waves frequencies or magnitude like that, then that data set is very important. Then we have to look at how the deforestation has been changed or has been continued since let's say few decades in that particular region like that. Or if you are interested in, let's say, snow cover and glacier mapping monitoring, then in that case we cannot install the point observation stations everywhere in that particular region. However, we are relying upon, let's say, the data set which we are capturing from the remote sensing devices or satellites like that. So therefore, these are the wide application areas, and depending upon the areas we select different types of instrument techniques and all, and then we use that data set for our enhancing the understanding of whether climate change has a significant impact on a certain region or not like that. Then there is another types of data set which is called, let's say, we have ground observation, which we have satellite observation. So suppose when you have observing the data at ground, it is basically highly accurate data, because you are collecting at one point data continuously, and therefore it will have a very good accuracy, because that is the at site data set based on the ground record. However, it is possible with the ground record, it is possible that we may not cover the wider areas, because it leads to more instrument cost or expansion network or maintenance, something like that. But satellite data can cover a larger region based on because of the coverage or global coverage like that. But in the satellite data set, there is a problem that it might have some sort of biases, errors, uncertainties in the data set. So how do we use that satellite data? So the solution is, we can use the satellite data set for one particular region. We can use the ground observation data set to correct the data or to remove the biases in the satellite data, and then we can use the final product for broader region applications like that. So that is how basically we can use the multi-scale observational data set and integrating the data from various sources, so that we can have broader coverage. At the same time, we can have low errors, so that we can make a more good decision based on the data set. So these data sets are called reanalysis data set, where we are integrating multiple source of the data, and then there is certain modeling component are also involved in the data. Modeling means we have understood about, let's say, the certain physical mechanism, and based on that we have written some sort of mathematical equations, and based on that we are simulating that equation process response, and based on that we are generating some data set. So the modeling based data set, the satellite data set, the observational record data set, if you integrate all these together, that is called reanalysis data, and there this kind of the data set will give more better insight about a certain information of region. So these data set can be ERA 5, NCEP or MERA or Terra Climate. There are so many other data sets which are available, where one can use the broader scale mapping or monitoring of climate change based on satellite modeling and ground observational records like that. So this is all about data types, what are the sources of the data, integration of the data to make more robust data sets, so that we have broader coverage and low errors, uncertainties like that. So what is the application of these data set in the climate science? As we have initially discussed, that it will enhance our understanding or implementation of, let's say, extreme event detection. It can give us more clarity about what type of extreme events are occurring in certain region, or what is the frequency, what is the 10-year, 100-year, 50-year, 25-year frequencies, and what is their corresponding magnitude. So that is basically we can get an idea about in a certain different region. Then based on that extreme event detection, we can also tell about what is the historical pattern, what is likely to be happen in the future condition, based on different types of data set which we have observed, and based on the trend analysis, anomaly detection and all, we can do some sort of climate monitoring based on those data set, and then we can based on that information we can plan for certain mitigation step or policy making, so that the extreme events at that particular locations can be slightly minimized, that can reduce the risk further. So that is the advantage of having good quality data and longer time record data to monitor the climate change in a certain regions like that. So this is the one kind of summarizing the strengths and limitation of tools. So for example, when we are talking about remote sensing tools or some sort of ground observations, so there is a ground stations, there are satellites, there are remote sensing data set, so this basically ground stations covers high precision sparse coverages, satellite data has global coverages but lower temporal resolutions, and remote sensing data set or reanalysis data set can have versatile or interpretation complexities like that. So these are some of the case studies which can tell us about the application of different types of data sources across different parts of the world. For example, this is the case study 1 where Arctic sea monitoring was done based on the satellite observations, based on annual record of what is the extent of Arctic ice and how it has been changed over the years. So the findings of this particular study suggest that the ice sheet or this ice coverage area in the Arctic has been shrinking significantly faster. Therefore, it could lead to us more global sea level rise, or more changes in the oceanic behavior in the near future like that. Then the case study 2 where ground station data for Indian monsoon trends, where this study has used multiple different data set which are available ground observation station across India, and they have done some sort of changing pattern or precipitation pattern across different parts of the Indian region. Then case study 3 basically tells about purely the remote sensing data set application on the deforestation study. This is Amazon basin, where they have done that what is the overall changes in the land use, land cover, or particularly the forest region in the Amazon basin, and they have found that a very significant change observed across the Amazon basin, let's say in the recent time period, and lots of region has been suffering from deforestation issues across this particular basins like that. So, this case study gives an idea about based on different types of data set can give us more detailed information, and these detailed information can be used in the process response modeling, so that we can understand that okay, let us say heat waves are occurring, what would be the impact on vegetation. Let us say if the flood is occurring more, what is the impact on let us say urban areas or urban settlements like that. If in a certain region floods are occurring more often, is there any correlation with let us say the rainfall extreme or temperature extremes, or let us say soil moisture anomalies or deforestation, something like that. So, this can give us a more idea about let us say how we can monitor or let us say model the extreme behavior or extreme changes in the behavior in different parts of the world like. So, this is all about historical data set, historical observations, or some sort of satellite data or remote sensing based data set. There are several new emerging technologies are also developing very significantly. For example, there is a advancement of CubeSat satellite launch, which basically can give us which are very smaller satellites, 10 centimeter by 10 centimeter like that. It's a cube, and then basically it can launch very easily, very inexpensive method, and can be placed in a very multiple orbit of the earth, and can multiple quantity of these CubeSat can revolve around earth, so that they can collect very precise measurement of certain different properties like that. So, that is also a very emerging technologies which are coming, and therefore we have a network of these satellites which can covering the whole earth, and therefore it will basically enhance our further understanding about different types of terrestrial, oceanic or atmospheric processes like that. Then artificial intelligence in climate data analysis, which also gives an multiple insight about how we can use complex climate data set to get an very a non-linear analysis using the artificial intelligence, so that we can have a better understanding about different processes. Or let us say one process is how another process are connected with each other using some sort of machine learning or artificial intelligence methods like that. Then high resolution remote sensing instruments, which are let us say UAV based, or let us say drone based or flight based, which are also more frequent now these days, and therefore using those technologies we can monitor a certain regions very quickly, and anytime whenever we are we need the data set. Or these also instruments are based on active remote sensing, therefore we do not need that secondary source of energy to continuously measure the data set, and therefore it is like some sort of more advancement in certain region. We can use that technology for continuous measurement like that. In the future direction, this data analysis or the climate data analysis are basically moving toward more real time data processing, so that we have more better understanding about different types of extreme events and their behavior, and we can make more informed decision based on less uncertain projections or forecasting methods, so that we can use those data set or analysis for better manage of all these extreme events, extreme conditions for different parts of the world, using the real data processing with the use of multiple different satellite data, ground observation data, or high resolution remote sensing instrument data like that. Then in the future direction, people are also working with integrating the citizen science. Basically they are also including multiple different source of the data set from the local record, or let us say the ground observations from multiple information from the multiple people also. So, they are integrating all these data set to get a more robust understanding about how these climate are changing and how they are interacting with a certain region, and therefore we are observing increasing activity of climate extremes in certain regions. So, this is all about climate data sources and observational tools, which are basically helpful to understand let us say what is exactly the pattern of extreme events, climate extremes in certain different parts of the world. In this lecture, we have covered primarily the ground stations data, satellite and remote sensing data set, and some sort of climate monitoring, which are very essential for. Then we have also talked about different tools which has different strength and different challenges. Then we have also talked about integration of data source from different source of the data and providing more holistic view of the climate system, so that we can have more better insight about different types of climate processes that can give us more better decision about mitigations on all these steps. Based on the today's class, maybe you can look at some of these tools which we have covered in this lecture, and look at some sort of specific regional climate issues in your region. Let us say you can look at ERA5 data, for example, or maybe you can look at satellite based or Sentinel-1 or Sentinel-2 data set, how we can use that data set for monitoring different types of land use land cover characteristics that can give us some more insight about how that land use land cover characteristics has been influenced by changing climate conditions, for example, or let us say deforestation issues in some sort of drought prone region, or whether drought is more occurring in certain region based on some sort of rainfall record based on reanalysis product, or let us say observational record. For example, IMD 0.25 degree data set can be also used for that types of analysis. So, this is for today's lecture. In the next lecture, we will talk about what is data collections and what is the pre-processing of the data collection, which we use for different types of climate analysis purpose. And we will more discuss about how we can remove some sort of errors and uncertainties or missing values in the data set or collection processes like that. Thank you so much.